Let's take a look at an example of using these rules and formulas that we just constructed by looking at this general example. Now, we're going to be checking this for different values of n. So we could say n equals 10, n equals 100, n equals 10,000 of this sum. I goes from 1 to n of this. Now, yes, you could do this by hand for each of these. Right, so when n equals 10, what you're taking is you're going to take 10 numbers that you could plug in. So you'd be adding 10 things together. You can do that by hand, right? Same thing with 100. If you wanted to add together 100 things by hand, you could. You could do 10,000 things by hand, but that gets ridiculous. So this is where using the formulas will allow us to speed this up no matter how big of our sum or how many terms we're going to include. We're going to be able to come up with a much more succinct way of dealing with this. So when we take a look at simplifying this, I'm going to plug in these n values at the very end. I'm just going to treat n as an arbitrary constant right now, and we'll plug in those constant values in a bit. So when I first look at this, I see that I can use this first property because n squared is really a constant with respect to this index of summation being I. I is the things that's changing, n is really just some number. So I can pull this out front. So I have, this is equal to 1 over n squared, the sum from I equals 1 to n of I plus 2. Now, when I have the sum of two things, I could use this rule here that says that if I'm adding these two things, I could now separate that. So I have 1 over n squared, and I'm going to be adding the sum from I equals 1 to n of I plus the sum from I equals 1 to n of 2. Then what I see is that I can use this rule number 4 right here because I'm adding i's from 1 to n, and I can use this formula. And here, 2 is my constant. I could use this formula. So I'm adding 2 n times together. So this becomes 1 over n squared, and then this one we said is going to be n times n plus 1 divided by 2 plus the sum from, or plus 2n. Then I can distribute this back inside. So I could distribute the n squared. So I would have an n times n plus 1 divided by 2n squared plus 2n divided by n squared. I can cancel out some of these n's, and then I could find common denominators. So I would have n plus 1 divided by 2n plus 4 over 2n. So what I had left was going to be 2 over n. Common denominators was 2n. So I multiplied the top and the bottom by 2, and I got this. So this gives me an expression of n plus 5 over 2n. So this whole thing, this whole sum, can be simplified to this formula. And notice now this is going to be very easy when I plug in values of n. So when n is equal to 10, this sum from I equals 1 to 10 of I plus 2 over 10 squared, this is going to be equal to 10 plus 5 divided by 2 times 10. Or in other words, this is equal to 15 divided by 20. Or if we do this as a decimal, this is going to be 0.75. N equals 100, so if I try the next one, I have the sum from I equals 1 to 100 of I plus 2 divided by 100 squared. Plugging in n equals 100 into this formula, I get 105 divided by 200. In other words, this is going to be 0.525. And then I could plug in 10,000, n equals 10,000. Sum from I equals 1 to 10,000 of I plus 2 over 10,000 squared. Again, plugging in 10,000 here for n, I'm going to get 10,005 divided by 20,000. So it's going to be 5000025, I think. Maybe it's this. I don't know. Nonetheless, but this is plug that into the calculator. This is what you get. So if you notice, if you're thinking about limits, limits will start to appear here. And we might notice that as n gets really, really, really large, we could calculate what this limit will be. So hold on to that idea. We will approach limits in a little bit. But right now, just get the feeling of how do you use these rules to help simplify an expression like this.